Dear friends, in the last lecture we started inverse Laplace transform. Okay, and we have seen some examples of inverse Laplace transform, and we see first shifting theorem. Okay, and what is the use of first shifting theorem in inverse Laplace transform? So let us continue our topic. Use of shifting theorem. Use of shifting theorem. You can say first shifting theorem. First shifting theorem. Use of first shifting theorem. See here the statement is what? The statement is if L inverse of function f of s and which is equal to what? F of t, which is equal to f of t, then we can write L inverse of f of s plus a is equal to what? S plus a equal to e raised to minus at, because a is here, and f of t. Okay, but this f of t is what? This f of t is what? L inverse of f of s. So we can write e raised to minus at L inverse of, yeah, L inverse of f of s. Okay, this is first shifting theorem, or you can say first shifting property of inverse Laplace transform. Okay, now let us do the problem based on this. Then you will understand what is the first shifting property of Laplace transform. Okay, so the problem, or say example, find the inverse Laplace transform of, find the inverse Laplace transform of the function. You have function uh, s upon s square and plus 2s and plus 2. Okay, let us see how to find inverse of this function. So solution of this, we first write down, given that f of s, is, f is the function of s, that is what? S upon s square and plus 2s and plus 2. Okay, so therefore this function can be written as what? F of s equal to, okay, first we write denominator, then we adjust the numerator. So this function can be written as s square plus 2s and plus 2 can be written as what? 1 plus 1. Okay, 2 can be written as 1 plus 1. So this is what, and the numerator we write here yes. So this can be written as s upon, so s square plus 2s plus 1 can be written as what? S plus 1 the whole square. Okay, and plus 1,
Yeah,
1
one
can be,
square. One square.
written as 1 square. Okay, now what? Now we adjust the numerator. Here s plus 1 is here, so we add and subtract 1 in the numerator. Okay, so we write here s and plus 1 and minus 1. Is there any change in the numerator? No. Is there any change?
No,
If I,
sir.
okay, if I adding and subtracting 1 in the numerator, so there will be no change. Okay, so s and plus 1 the whole square and plus 1. Okay, now we separate this. Now we separate this. So we will have just take inverse Laplace transform, then separate it. Okay, or you can separate then apply inverse Laplace transform. So we first separating this. So s plus 1 I'm writing in the first bracket and divide by what? S plus 1 the whole square and plus 1 square. Okay, I'm writing here 1 square, and minus 1 upon s plus 1 the whole square and plus 1 whole square. Okay. Now apply inverse Laplace transform on both sides. So here we writing applying inverse Laplace transform on both sides. Inverse Laplace transform on both sides. Okay. So just move to the next page, then simplify it. Okay. So this equal to what? I am applying inverse Laplace transform on both sides. So L inverse f of s. Okay. And this equal to L inverse, and the first bracket, your first bracket is what? S plus 1 divide by s plus 1 and divide by s plus 1 the whole square and plus 1 square. Okay. And the second term is negative of 1 upon denominator. What is the denominator? S plus 1 the whole square and plus 1 square. Okay. Now use here linearity property of Laplace transform. So we will have L inverse of S plus 1 and divide by S plus 1 the whole square and plus 1 whole square. Okay. This is the first term, and minus L inverse of second term, that is 1 upon S plus 1 the whole square and plus 1 square. Okay. So what are the inverse of this? Use shifting property.
Cos
So
t.
use shifting property. See here, I am using shifting property of inverse. So you will have, see here s plus a, s plus a is the plus sign. So we will have e raised to minus, here plus, then exponential will be minus e raised to minus t. Okay. L inverse of s upon s square and plus 1 square. Okay. And negative of this is what? This is your e raised to minus t, e raised to minus t, L inverse of 1 upon s square and plus 1 square. Okay. Why this so? Because of shifting property of Laplace transform. Okay. So you know very well what is the inverse of this. So this is e raised to minus t, and this is what? Cos t, s upon s square plus a square, that is what? Cos square. Here a is 1, so cos a is 1, so cos t, and minus e raised to minus t, here will be what? 1 upon a sin at, but a is what? A is 1, so there is no need to write 1 upon a, so just write down sin t. Okay. So e raised to minus t, e raised to minus t is there, so just you take outside. So e raised to minus t and cos t minus sin t. So this is your require inverse Laplace transform of given function. I hope you understood this problem. Yes or no?
Yes, sir.
Is there any doubt to anybody?
No, sir.
No? Okay. Let us do the next problem. Example number 2. Example number 2. Find the inverse Laplace transform of inverse Laplace transform of the function. I am writing function that is 6x minus 4 and divide by s square minus 4s and plus 20. Okay. So let us see how to find the inverse Laplace transform of this function. So write down solution. So we first write down let f of s. F of s is what? Your given function, that is 6s minus 4 and divide by s square minus 4s and plus 20. Okay. We first simplify the denominator. we first simplify the denominator, then go for the numerator. Okay, this is the basic step you must remember. You first simplify denominator, then go for numerator. Okay, so this is equal, therefore f of s equal to 6s minus 4 and divide by s square minus 4s. See here, I am breaking 20. Okay, I am breaking 20. So plus I am writing here 4 and plus 16. Is there any change in the denominator? Is there any change? Yes or no?
No,
No,
sir.
sir.
Yes, no change. So we write here numerator 6s and minus 4. Okay, and so this factor, this s square minus 4s plus 4 can be written as what? S minus 2 ka whole square. S minus 2 whole square. If you opening this, you will get s square and minus 2ab. 2 means 2 to the 4 ab. 4, yes, yes, and the square of this, that is 4. Okay, and plus 16 can be written as what? 4 square. 16 can be written as 4 square. Now we got the idea to adjust the numerator here. We adjusting to such that we can take common 6 from the numerator. Okay, so for this what I have to do? What I have to do for this? We writing the next step once again. 6s minus 4, 6s minus 4 and divide by s minus 2 the whole square, s minus 2 the whole square, then plus 4 square, plus 4 square. Okay, what I have to do here? Here 6 is here. Okay, we want to take 6 as a common. So for this what I have to do? So we write here 6s and minus 4. If I subtracting 8 and adding 8, okay, so this become what? 12. So you can take 6 as a common because 12 is the multiple of 6, and divide by s minus 2 the whole square and plus 4 square. Okay, so now simplify this. 6x minus 12 and plus 8 and divide by s minus 2 the whole square and plus 4 whole square. So this equal to what? I am taking 6 common from the numerator, so this become s minus 2. 6 to the 12. Okay, 6x minus 2 and plus 8 and divide by s minus 2 the whole square plus 4 square. Now you can separate this. 6 s minus 2 and divide by s minus 2 the whole square and plus 4 whole square and plus 8 divided by s minus 2 the whole square and plus 4 whole square. Okay, now apply inverse Laplace transform on both sides. So just applying inverse Laplace transform on both sides. Inverse Laplace transform on both sides. Okay, so just apply the inverse Laplace transform. So L inverse of f of s, and this is equal to what? L inverse of 6 times of s minus 2 and divide by s minus 2 the whole square and plus 4 square. Okay, the next term is 8 upon s minus 2 the whole square and plus 4 square. Okay, now apply linearity property of Laplace transform. So 6 is a constant term, we're taking outside. 6 L inverse of s minus 2 and divide by s minus 2 the whole square and plus 4 square. Okay, and plus 8 is a constant term, take outside. So L inverse of 1 upon s minus 2 s minus 2 the whole square and plus 4 square. Okay, so this equal to what? 6. Applying shifting property, e raised to, here minus sign is here, s minus 2, so here will be plus 2t 2t L inverse of s upon s square plus 4 square. Okay, this is first term and plus 8. Applying shifting property here, so e raised to 2t L inverse of 1 upon s square plus 4 square. Okay, so let us move to the next page, then we write the answer. So therefore we have L inverse of f of s. Okay, and this is equal to 6 e raised to minus 2t, 6 e raised to 2t, not minus 2t, 6 6 e raised to 2t. Okay, L inverse of s upon s square plus 4 square, 4 square, s upon s square plus 4 square and plus 8 e raised to 2t and L inverse of 1 upon s square plus 4 square. Okay, so this is what, this is equal to 6 e raised to 2t. Okay, and what is the inverse of this? S upon s square plus 4 square, that is cos 4t and plus 8 e raised to 2t, and here 1 upon 4, 1 upon a is 4, 1 by 4 sine 80, a is here 4, that is sine 40. Just simplify this. So
सर
हाँ,
सर अपना साइन 2t समझ साइन 4t का फॉर्मूला था अपने पास a अपॉन ए स्क्वायर प्लस ए स्क्वायर।
हम्म,
तो सर यहाँ पे a में देखो ना 1 आ रहा है ऊपर
कहाँ वन है? ए देखो,
ऊपर।
ए भाई ए देखो, व्हाट इज द फार्मूला फॉर साइन, व्हाट इज द फार्मूला फॉर Laplace transform? What is the Laplace transform of sine 80? Sine 80. This is not inverse. This is only Laplace. Okay.
हाँ
This is Laplace transform of sine 80 is what? A upon s square plus a square. Okay. If I taking inverse, okay. If I taking inverse, so what happen here? Sine 80 and L इनवर्स, ए इज कांस्टेंट ना, तो ए आपका बाहर हो जाएगा, ए इज आउटसाइड, एल इनवर्स ऑफ 1 अपॉन एस स्क्वायर प्लस ए स्क्वायर, तो ए आपका इधर आएगा 1 अपॉन ए साइन 80 इक्वल टू व्हाट? एल इनवर्स ऑफ 1 अपॉन साइन स्क्वायर प्लस ए स्क्वायर। ठीक है, ए वाला है, इसका क्या आएगा? 1 अपॉन ए क्या है आपका? 4 है, एंड साइन 40। यू
अच्छा
अंडरस्टूड?
सर। हाँ ओके।
अंडरस्टूड दिस?
यस सर।
Because a is constant na, here a is constant, so you can write like this, sine 80 upon a. Okay, have you understood this?
हाँ सर।
uh, so let us write down this in more simplified form. So 6 e raised to 2t and cos 4t and plus 4 to the 8, 2 e raised to 2t and sine 40. Okay, you can take 2 e raised to 2t as a common, so 2 e raised to 2t common, so here will be 3 cos 4t and plus sine 4t. Okay, so this is your require inverse Laplace transform of given function. I hope you understood this. Yes or
जी
no?
सर।
Is this easy for you?
हाँ सर।
आसान है ना? Yes, बहुत मजा आएगा करने में आपको. Should I give exercise problem for you?
Yes, sir.
हाँ, तो एग्जाम्पल्स फाइन find the inverse Laplace transform the following following. Number one is 3s minus 7 divided by s square minus 6s plus 8. Number 2, s upon s square plus 6s and plus 17. And number three s upon 2s upon 2s plus 1 the whole square. Okay, so please do this problem at your home. See what I have to do over here. ये तो अभी जैसे किया मैंने वैसे करना है आपको. ओके, आपको ए फैक्टर खाली ए लास्ट के 2 आपको ऑब्जर्व करना है. एस स्क्वायर माइनस 6x, इसमें देखो ये किसका स्क्वायर बनेगा. ओके,
-3.
हाँ, ये एस -3 का होल स्क्वायर बनेगा. ठीक है, तो यहाँ से आपको ऐसा फैक्टर बनाना है, क्या है, क्योंकि न्यूमरेटर में आप एस -3 ला सको. ठीक है, ऐसा फैक्टर एड और सब्ट्रैक्ट करना है. ठीक है, इन दिस प्रॉब्लम व्हाट हैव टू डू, यहाँ पर भी आपको क्या एड एंड सब्ट्रैक्ट करना है कि यहाँ पे फैक्टर बने. किसका फैक्टर बनेगा, एस +3 आएगा यहाँ पे. ठीक है, आपको न्यूमरेटर में क्या एड एंड सब्ट्रैक्ट करना है वो आपको देखना है. और यहाँ से आपको ये देखो 2, इसमें कभी भी एस के साथ कोई भी कोएफिशिएंट नहीं रहता है, एस हमेशा अकेले रहता है. तो फॉर दिस व्हाट हैव टू डू, वी टेकिंग 2 एज आउटसाइड. ठीक है, कॉमन निकालो
तो
उसको.
सर पहले इसको स्प्लिट करेंगे, तब
नहीं
उसके बाद 2 कॉमन लेंगे ना.
नहीं नहीं, पहले ही आप कॉमन ले लो,
तो 2
क्योंकि
स्क्वायर कॉमन लेना पड़ेगा क्या,
हाँ, तो
क्या लेना पड़ेगा.
2 कॉमन निकालो इससे. तो ये देखो स्क्वायर है तो बाहर आएगा तो 4 आ जाएगा. ठीक है,
हाँ,
हाँ, और ये नीचे आ जाएगा इसके, यहाँ नीचे आ जाएगा तो 1/2 हो जाएगा यहाँ पे. ठीक है, बाहर में क्या आएगा, 1/4 हो जाएगा, और यहाँ पे एस प्लस 1/2 रहेगा. तो आप ऊपर देखो आपको क्या ऐड करना, ऐड एंड सब्ट्रैक्ट करना है. यही ऑब्वियसली यही करना पड़ेगा, 1/2 ऐड करना पड़ेगा और सब्ट्रैक्ट भी करना पड़ेगा. ठीक है, देन आफ्टर यू सेपरेट एंड अप्लाई शिफ्टिंग प्रॉपर्टी. आई होप यू अंडरस्टूड हाउ टू
जी
सॉल्व
सर.
दिस एक्सरसाइज प्रॉब्लम. बहुत आसान है. ठीक है.